Hello, and welcome to the Professor Podcast with Ruth and Claire. Each episode, we talk about a particular topic in the life of a professor. Ruth is a visiting professor at a large university in Ireland, and Claire is an associate professor at a primarily undergraduate university in Northern California. The purpose of our podcast is reflection, so we bring something we think is working and something we're working on to discuss.
You have people coming from a variety of viewpoints, and I really didn't want things to reach a stopping point. Like, I didn't want to get dead ends. I didn't want people to get hurt, but I wanted people to think critical. Like, that's really the goal at the end of the day. It's just like critical thinking skills.
Welcome to the Professor Podcast with Ruth and Claire. I'm Claire.
And I'm Ruth, and we're coming back from the summer with a banger here. So Joel Destino, an assistant professor of chemistry at Creighton University, talks with us about including environmental and social justice in his analytical chemistry class. We're going to talk about his approach and the benefits of the added context.
So I first met Joel at a workshop on active learning and analytical chemistry back in 2018, and then we reconnected this past summer at the Cottrell Scholar Conference. We were chatting and catching up, and he mentioned having explicit discussions about the EPA and the government in his classes, which I was very excited to hear more about, particularly because he was incorporating these topics into a core science class. Through these discussions, it quickly became clear that he'd be a great fit for the podcast, and we're very excited to share Joel's insights and experiences with you.
And also, we just switched to a new hosting platform for our podcast, so do please let us know if you're having any trouble. And so now, back to Joel.
Welcome to the podcast, Joel. We are delighted to have you on the show.
Thank you. I'm glad to be here.
So Joel, could you give us a little bit of context about your teaching? So like, what kind of classes do you teach? How big are the classes? And what is your university like? So just kind of getting a bit of positionality of what your classes are like.
Thanks, Ruth. Yeah, so I'm at Creighton University, which is in Omaha, Nebraska. We are an interesting school in that we are primarily undergraduate institution. However, our institution has a lot of graduate programs, but just our chem department does not. So our department is entirely undergraduate, and I teach analytical chemistry. In the past, I've taught quantitative analysis, instrumental analysis, lab, and lecture. So, and our classes vary in size. Quantitative analysis is probably about 20 to 30 students. Instrumental analysis is usually between 30 and 40 students. And we have multiple sections of labs, so labs aren't, the whole 40 students. That would be pretty overwhelming.
Yeah.
So our lab sections tend to be about 10 to 12 students. Yeah.
Wow, so you're almost Claire, but somewhere else.
I know.
I was like, oh, wow, that's really, yeah.
It's really cool. I teach those exact same classes, similar sizes. Our department doesn't have a grad program either, so it's really cool parallels there.
Yeah.
What motivated you to include environmental justice in your analytical chemistry classes? Like, where did that idea come from?
Oh, this is such a good question, because I think when I saw I was going to be asked this, I had to think myself. And, there's sort of this thing that happens where you think every idea you've ever had, you've just always had, like it's been with you forever.
Totally.
And you're like, well, I've always done that. And then you look back and you're like, oh no, there was a moment when I started doing this. And for me, actually, I think a lot of it came out of 2020 and sort of this idea of we do a lot of teaching of concepts that are really relatable and applied in analytical chemistry, but we don't often draw them back to societal issues, and we don't often draw them back to bigger pictures in a way that we actually have reflection and really think about what our role is and can be. And so around that time, I started looking into the literature on what other people are doing in terms of service learning, social justice, environmental justice topics. And actually, I found a ton of stuff at the high school level. There was a paper at the time in the Journal of Chemical Education on Flint, Michigan, which I had covered too in the past. I think that analytical chemists have been using that now for the last 6 or 7 years. Probably most people mention, if not cover, a good amount of topics related to Flint, Michigan, and the water crisis there. And so I was like, how do I really sort of intentionally integrate justice-centered topics into my coursework? And so that's started about then. Again, like I said, summer 2020.
Wow, this is already just blowing my mind so much. Because I guess you just feel like physics and chemistry are kind of sister subjects, do you know what I mean? And
oh yeah,
but it really is cool that you could go out and be an agent for change. I mean, I'm sure I'm just not thinking of the ways that physics could do that, but you're really teaching people when you're doing analytical chemistry, like they're getting skills that could go out and actually really impact people's day-to-day lives. That is, sorry, I know you guys know that, but I'm just figuring that out for the first time. I'm like, oh, that's amazing. But that's really cool.
It's funny you should say that, because in my department there's almost like a joke about analytical chemistry. We joke like the other chemists say it's like the class that gets students employed. And it was something that like, yeah, like it's true, a lot of our students with 4-year degrees will become technicians, or they'll become analysts, right? So whether that be quality control or environmental or other things in industry, a lot of them become analysts. So it's actually, very true, but it's also just because it's so like inherently applied, and you can apply it a lot of different ways. Yeah.
That's very cool.
Yep.
So can you talk more about the discussions that you're having in your classes? Like I understand that you talk about the EPA, the government, society, scientists' roles in all these things. First of all, I guess, would you call all that environmental justice? Is that like a umbrella term for what you're talking about?
I think I always just refer to what I do as like justice-centered curricula. I think that like environmental justice and like social justice have specific like emphases that I think are, a little bit more directed. And I think that, I tend to teach modules that are oriented one way. And so I forgot to say this too. This reminds me, and you mentioned the EPA, and I'm like, oh, geez, this is another thing that, again, back to the many things you forget that kind of create these ideas. Is I'm originally from Niagara Falls, New York, which for people who know like environmental science has like a famous history there's this place called the Love Canal, which was the first Superfund site in the EPA's history. And it sort of created this, social dilemma of we have people, developing in spaces where there is, large amounts of toxic and chemical waste from industry past. And so I grew up kind of with that knowledge and that awareness about how it influences society, and how environmental justice really comes down to, how do we take care of the environment, but then there's the social justice aspect of how do we also take care of people by being good stewards to the environment. And so that's something that I've always kind of carried with me and that I often forget about. But when we get to have these topics, it really comes out. So I know I didn't answer your question at all. but I think that they're all very related. And I do think that people who maybe even do the justice-centered topics even better than I do, and I know there's people who teach, say, environmental justice courses that really are about getting out into the community or into environments and sort of thinking about, what's going on and how can we, do projects that sort of work towards a specific goal. Whereas I kind of use it more so as a curricular framework to create, to frame the content. And so I do want to kind of draw a line and say, there's even better people who are doing actual projects that have very specific goals in local, regions that actually sort of have the goal of putting the environment, center and making sure that it's that people are being good stewards and in remediating and doing other things like that. So I do think that there's like levels, but I know that you guys have talked about this in other episodes. There's like, sort of different levels that work for different people. And I guess for me, where I've been for the last 2 going on 3 years is kind of this idea of sort of introducing a variety of topics and at least to sort of pique students' interest. That's sort of where I've found a sweet spot for me in terms of like doing environmental justice-centered topics. But then I know that you also in your question had something about how do you like create the conversations and all that. Is that correct?
Can I sweep in with a question? So do you know when you were saying module? So does that mean like this feels like, you're probably going to be like, does this lady actually teach classes? But do you break your semester into modules then? Do you know what I mean?
Yes. So what I typically do is like we have units that are based literally on chapters and topics. So for example, if there's like chromatography topic or a spectrophotometry topic, and then within those, within units, and then so the spectrophotometry unit and then the chromatography unit. And then within that unit, I might have like specific activities I want to accomplish. Or learning objectives, and then I'll have activities that support those learning objectives. Sorry to make that clear. Sometimes the lingo, I get a little tied up, so I apologize.
No, that's perfect.
But Yeah. So yeah, the activities are really the ones that are, environmental justice themed or social justice themed, and then they support specific learning objectives within a unit. Does that make sense?
Yes, perfect.
Yeah.
And so do you have a specific environmental justice module, or is it sprinkled throughout the other?
So I do a specific environmental justice module during separations, and that one's oriented on, and one of the beauties of environmental chemical analysis is that it has like, it's rich in chemical separations because you have sort of preparatory techniques, you have concentration techniques, you have analytical techniques, and then you have so just sort of from a content perspective, there's lots of angles, but then from a environmental perspective, we're talking about, I need to, here's an issue presented to us. We're talking about, for example, the framework I use for that unit is particularly is persistent organic pollutants. And then we get into a little bit with like chlorinated biphenyls, so polychlorinated biphenyls, and we'll talk about aromatic hydrocarbons. And so we talk about sort of these persistent organic pollutants that have been identified by major world industry or organizations, like the UN or other or agencies as sort of molecules of sort of great risk to society and environment, and in this case, really more so the environment. And then we talk about, how would you do sampling, how would you do analysis in these settings, but really. What's interesting is we can integrate those really tougher conversations as more sort of applied conversations about like what are the roles of people, local governments, non-government agencies, government agencies like the EPA, like within this framework of also talking about separations. So
That's that. Okay, so I love what you're talking about.
Yeah.
I love that you're talking about sprinkling all these different
Yeah.
ideas throughout to spark student interest, and I love that you're taking this environmental application and using it as kind of a framework to go through a whole bunch of different important topics in analytical chemistry. So then, how do you get the discussions? Like when you get to this more discussions, what's the ethics? What should we do? How do you actually talk about those kind of things in the classroom?
So in the classroom, what we typically do is, I think one of the things that happens when you present an issue, specifically one that has like an event associated with it. So if I talk about like Niagara Falls and we talk about like, dioxane or certain, say, molecules that have like a historical, significance for being, bad environmental pollutants. It's like there's like almost this immediate reaction of just like, oh, that's so horrible, and it's almost like empathy or sympathy that you get a ton of from students, but you almost like want to like turn it into dialogue and then like motivate it and like get them to be motivated to talk about it in terms of a bigger context. And so that was like one of the things that I learned when I first did this was that students are really like have a lot of emotion and a lot of, they're drawn to it because of that like tie. And so one of the things is like, okay, well, how do I like channel this into conversations? And so, the first year I did this, we had like discussion board posts because we were hybrid. And I was like, we complete this unit, we do these readings. I noticed that students are really empathizing with these issues. And so I wanted students to have these conversations. So I think the prompt was to like, read a paper. And they were like relatively popular. So this isn't like journal manuscript type papers. This is light reading. And then sort of reflect on sort of what the roles of the different players are. Mm-hmm. Because one of the things I learned too is in class conversations is things can get polarized, but they don't need to be if we're just going to like dissect the situation. And then we're going to think about it and then come take a step back, dissect it, take a step back, and then reflect on it. Because that was really important to me too, is I'm in Nebraska, and I'm at a Catholic institution in Nebraska, which is relatively conservative. And like any other place of higher ed, we are quite liberal here on campus, but you have people coming from a variety of viewpoints. And I really didn't want things to reach like a stopping point. Like I didn't want to get dead ends. I didn't want people to get hurt. But I wanted people to think critical. Like that's really the goal at the end of the day. It's just like critical thinking skills. So I think that was really important when I first taught it, is just sort of like dissecting viewpoints and being really objective about how we approach it. And then we can reflect on it afterwards. because almost the emotional side of it is the part that's like really hard to deal with, and that's definitely not my skill set as a
But this is
scientist.
always my phobia, right? It's like you're going to
Yeah.
open the can of worms or Pandora's box and suddenly everything is going to like catch fire and it's all terrible. So like has it happened for you? Because I've had some massive missteps in my diet, like where things have gone sideways. So has it happened where someone is like, well, is the earth even round or whatever? I can't even, but like has that happened, or is it because you're really talking about it through a specific lens of how would we do this problem, or you know what I mean? Like, does that take the sting out of it a bit?
I think it does. And I think that, I think that if you get people to think this is a real problem that has to be solved and we have to do something that's like in the best interest of everybody, and this isn't an issue that is like here to, I don't do I don't do reflections or anything where students have to persuade me something to do something. I really try to I think that that's when things become tricky, is when we start playing, advocate for sides, which I don't think is a problem, if someone's really good at navigating those spaces. I personally am not.
I am not.
I'm so
either,
great at
yeah.
navigating those spaces. And I think one of the things you learn, right, is like when you find yourself sort of dividing up into, binary oppositions, or binary perspectives on a topic, is that there's like so much subtlety lost.
Yes.
And I think that that's really what I want them to get out of it, is all the subtlety. So like the complexity of like, we have to do what's best for people, for the environment. We have to create we have to create policies that are actionable. We have to have sort of oversight that can then also keep these agencies that are maybe say have some interest, whether they're government or industrial, so we need now this third party to sort of keep them in check too. So we have this balance. I think it's really about systems thinking and sort of just like, how does this play out from beginning to end? And, and I think that has served me well because, like I said, I'm just not a confident person when it comes to navigating sort of those more emotional, more polarizing topics. And I think also for me, at least, they don't have to be. I'm sorry, I'm touching my mic.
No, you're fine. But like, do you have students who are like, we should burn down the company that did this? And like, or like, does that?
Yes.
Yeah.
Yes. Like I said, I learned that that's like the emotions are the easy things to actually play on, and that's what gets them in. And I think that that's the easy thing. And, but I've had people say things like the government has to do more, right? Like, and that's another one that I think happens a lot. And I always think of like my hometown as like a great example, like Niagara Falls. The city of Niagara Falls is like the people that they had this land from this company this chemical company that closed in the 30s. They sold it to a school board for like $1 or something like that to develop a community on top of it. And it's like, well, like governments can, and then of course, when this became an issue and they realized that they were on this canal that was filled with chemicals, it became an issue of, like governments can be bad actors too. And, you really need to have a balance of things. You can't just, and companies will try to a point to get things, to be good stewards. But really, not to the point where to the point where they can afford the the cost of the repair. And same thing with governments. Governments also have their best interest in mind. So it's sort of this idea of you need this balance and this variety of viewpoints, because there's just certain people that will say, oh well, it's got to be this way, right? This is the one thing if we did this one thing, it would all be better. And it's like, these are really complex issues, like and things just don't get better by making one thing. And then it's like, and I think that's actually one of the questions that I really always love the response the most, is like, what is the role of the chemist in this place, right? And I think that's actually really interesting. Yeah. It's like, you ultimately have to do what's best to do the analyses in an unbiased way. And then you have to report those analyses with the information you have. So of course, there's going to be a sort of like EPA or other agency standards on what is like an acute problem for human health. But then, it's like, are those even, true? Because even that has some amount of debate in it. And so it's one of these things where you realize we're just creating systems and rules and understanding, how to interpret and build. And your role as a scientist is to do what's best, and it's not really your role to serve, a party.
Wow.
In any sense.
Yeah.
Yeah.
God, because I would have no understanding of the subtleties involved, and I would be like, we should burn the company down. Like, that would be my thing straight away. So it's super interesting thinking about all of the different players.
Yeah, I love that big takeaway.
Yeah, and I make that very clear too. I'm like, I am not, I think I am a scientist. I am not a sociologist. I am not a public health expert. I am not a policy guru. But at the same time, like, I'm not telling people that they have to like unquestion, not question those authorities on those topics. More so, I'm just saying that, know what our role is, or your role in this question as the scientist, know who the parties are in their roles. And then sort of how do we create actual progress from that point as opposed to, data-based, progress, based in sort of actual real data from analyses that have been determined or been done and built forward. Because I think that that's how I've navigated this. And I've done very well. Like I've never had anyone, say, horrible things about me for doing these assignments.
That's good.
On evals either, because how evals are just this weird thing where
Yes.
things pop up that you didn't even know were a problem, and you're like, oh, you sat on that for 3 months and didn't tell me once? You could have told me you didn't like that I post the homework, a week in advance and wanted it 10 days in advance. I would have done it.
Yeah, totally.
I love too how you're bringing it back to the role of the analytical chemist at the end of that, because I was kind of wondering, you get all these students thinking about this really important topic, and then what's the action? It seems like a lot of them would want to take some action, and so maybe some of them do go off into government or something like that. But the ones who are learning, I mean, you're in this analytical chemistry class, so let's focus on what is the role of the analytical chemist. So I love that. That's cool.
Thank you. Yeah, I think that's really important because I think a big challenge nowadays I shouldn't say nowadays, I think a big challenge in society, probably always, is this idea of who has what power, domain, right? Sort of this domain alignment. And sort of, I think it's really important that people do things as unbiased as possible. And I think that that's a really hard thing in analytical chemistry, right? We do group projects, for example, in lab. And when we do group projects, you get some students who are just like really eager to get a result. Like they want to prove that, I don't know, like this electrolyte water like has like, not the minerals it says it has or something like that. And you're like, oh, no, like this is like not how you approach science. You cannot come in at it from the perspective of like, you have to like find this thing.
Yeah.
You're not like, you're not gold prospecting. It's like you're limited to the data set you have, and you have to interpret it for what it is. Yeah.
So I would love to go back and hear all the details of how you actually enact this. So like you've got this wonderful topic of these organic pollutants,
Yes.
and you're doing a lot of analytical chemistry aspects of it. How does the discussions fit in? Like what does it look like if you hand me this is the assignment that we're going to be doing over the next few weeks? What does that look like?
Yeah, so it's usually a packet. And so when I do like a module supporting a topic, it's usually a packet. That packet would have usually some amount of reading assignments sprinkled throughout as well. So it's not just sort of a packet of questions that are just, practice type questions. They're sort of some like lighter reflection or like summarize things you've read topics. So for example, I had them read a section from the EPA on like the Stockholm Convention, and then I had them like list, the dirty dozen POPs, and then I had them maybe not reflect, but maybe like summarize some of the details about why these were identified. And then I have them draw the structures, which is trying to bring some chemistry in, sort of them thinking about what those structures are. And then we talk a little bit about like things that are important that tie back into old topics. So we talk about things like, why is it escaping me now? What do we call that? Partition coefficient. Jesus, Claire's going to be embarrassed for me. Yeah, so I have them like look up, some physical properties like partition coefficient. So I bring in like a lot of concepts. And then, I have them think about like, why do you think these molecules would exist in the environment or persist in the environment? What about their properties would suggest that? Where do you think they would persist in the environment? Where do you think they would be in greater or lesser quantities? And so I really have them sort of start from a chemistry perspective, and then I have a second half of that assignment in this particular one where we're talking about the EPA and the organic pollutants. Then we do more of an impact of these pollutants on society, and then we do a little more discussion about the actual sort of who are here's an example. So I have them actually read about Love Canal. Again, this is something that's like literally was in my hometown, and I grew up very close to it, and I heard lots of. So it's actually kind of interesting too. I have to say, like being from a town that has like sort of this infamy associated with it. Like I almost grew up knowing it more from this mythical angle than sort of this like technical angle. And sort of, so that's kind of interesting too, because even like as I learn more, it's almost surprising how different it is than what I thought it was.
Oh, because I'm sure when you were younger, you weren't engaging with the chemistry of what was happening. You were just, yeah.
Exactly.
Interesting.
Yeah, so it's super interesting, but I also give them the option to read other topics if they don't want to read that topic, because I also think one of the things that's important is that they connect. So I connect with this topic, so I can bring passion to it, so we do talk about it. But then I also give them the option to talk about something that's like relatively local in the town of Omaha. Or in the city of Omaha, there was a Superfund site around, I believe it was a steel mill where they had, and there's now like really high lead levels in that area. And I think it's almost remediated, or it's sort of it's within a certain year time plan from the EPA to be remediated, but it's on the remediation path. So I also do include that for kids that are for students that are from the region, so they can connect to that. And so that's sort of how I approach that. And then I'll bring back the third part of the module, brings back chromatography, and now we'll actually talk about. So the first section was talk about sort of molecules and their properties and where they persist. The second, sort of impact on society. And then the third is like chemical separation. So actually bringing it back to analysis. And now we're going to talk about, how do we actually separate these things and different techniques for doing that and measuring them in real samples.
That's lovely. And so then they're talking about how would we remove them from the environment? Is that what they're doing in the separations?
So analysis and removal. So we talk about with extraction. Yeah, we talk about the extraction and analysis. Mm-hmm. Yep. So that's
great. I love that you can get all this chemical discussion in with this really specific example. That's really cool.
Exactly.
And then is all of this...
Oh,
go ahead.
Oh, no, you go ahead.
No, Claire, you go. Honestly, I'm just rambling about
Okay. Is all of this happening in lecture, or is there a lab component of this as well?
No lab component yet. However, I was just talking to my colleague, and we have some ideas for some other service-oriented projects that aren't exactly related to this. In the past, we have done, or not in the past, we've always done, since I've been at Creighton, a group project portion of instrumental analysis. We have done lead determination in soils, but not specifically from the Superfund site. So it's not like we've actually collaborated with like local partners to do that type of analysis. But I think that'd be something that'd be great to do. I know that there's other topics that are also equally as engaging. I've talked to other people about other topics to do. So I think we do have an interest to bring sort of service learning, either environmental or social justice centered service into the lab, but we haven't done that yet.
Yeah. So I mean, that sounds really cool to connect it. I mean, even the current instrumental analysis analyzing lead in soils sounds like it's still connected, and I'm sure that they find that connection. And so the current format then is small group discussion and then whole class discussion. Is that right?
That's right. Yeah, that's right. So these packets basically are done partially in class, partially at home. So it's not really flipped per se, but it's it kind of flows in and out of class. So there's certain questions, like readings, for example, are done outside of class. So anything that's reading oriented, students would come to class prepared with as if it were homework. And then sort of the more discussion topics, the discussions happen in class. And we, of course, go over things that they were supposed to retrieve from the reading. So there is sort of a correction phase, but that's mainly just to make my life easier on grading.
Yeah.
So
always good.
And so what's the kind of time, how long does this packet take, basically?
So this particular packet is 7 pages, and I think but it's got a couple reading assignments, and that's about a three section time. So basically 3 hours, I would say, of class time. Yeah.
Do you grade the packet?
Yeah, they submit them as like homework grade.
Okay,
it's
cool.
actually, the packet I treat it as homework, even though we work on it in class. But it's, it's funny is I went to high school and I really hated packets because I had a lot of packet teachers, and I came to college and I didn't get any packets, and now I teach college and I find them very, very easy to use. It makes my life a lot easier. Yeah. And so it's almost an interesting thing because I don't love the idea that I use packets in some ways, but I also think that it makes things very easy, at least, like I said, from a grading perspective. And I can know where to expect the results, and I know that it puts everything in one place.
Yeah.
So, yeah.
Now, is a packet like a worksheet? What do you mean by packet?
Yes.
Okay. And so the idea is they're filling in things in
Yes.
very particular places. And what are they filling in? Sometimes it's calculations about separating compounds, and sometimes it's responses about, written responses.
Exactly. It's a mixture.
Cool.
Yes. It's
Cool.
a mixture of reflection, sort of what I would call information seeking, and reporting, obviously. So then I know that they found the information that they need to move on to the next step. And then there's just, sort of the standard calculation type questions.
And so they do. So you've got, did you say it was like, how many lecture periods does this?
3.
3 lecture periods. So over 3 lecture periods and homeworks, they've completed the whole packet and the whole topic.
That's right.
Is that correct? Okay, cool. That's
right.
neat.
Yeah. Yeah, I think it's interesting because my colleagues do this quite often, and I like I said, I've now latched on to the packet approach, but it's just really nice to put it all in one place. And I think then also too, students see it as sort of a body of work as opposed to these like disconnected themes.
Which I think, because that's like a thing that I've really only started to engage with mentally, is the idea of like expert and novice learners, and the fact that like we can group stuff together and it's clear like this is a unit of learning, but it's not always clear to the students. So I actually love the packet idea.
Yeah.
I love that too. Yeah. I feel like it fits really well. If you're lecturing and writing stuff on the board, you can organize it in a fashion that hopefully if they look at it over again later, it'll make sense. But here you've kind of taken the group discussion and group work and still kept that wonderful structure that you can have from the lecturing in this small group work and more discussion-based format. So that seems really cool.
Yeah, and like I said, it makes grading very easy.
Yeah,
and I know that they got the information they need, and I know that they're building the skills that I want to. So in terms of assessment, it's really helpful, in evaluating student progress. So.
Now, do they all hand in individual packets? They don't do them as a group? Okay,
they do not do them as a group. Yeah.
Okay, and are they doing all the work on the packet as homework, or do they chat about it? How does it work?
They can do it during class time because we will address a lot of it during class time. And like I said, they can correct it even during class time if there are things that they're like, oh, that's a great idea. I wish I said that. Or, oh, I guess I might have missed where this was really trying to go. They can make those adjustments on their own. And then they just submit it at the end. So it's really kind of participation in some ways. But I've called it homework just because there is some amount that's done outside of class. Usually reading, like I said, reflecting, maybe some calculations. But it's mostly done by individuals and submitted by individuals. And I'll say this too, like I know it's like a physical packet, but I feel like it's worth saying too that it's like posted as a PDF. A lot of students just keep it on a tablet and they kind of work on it as they go. Not a lot of students. It's not like I don't print these and hand them out either. Like I'm like, I really don't like printing just because I don't like carrying around printouts.
Yeah.
So I will say that too, like, there's a lot of students who, kind of work on it on their own and their tablets and that has made things a lot easier in terms of packets too, whereas I feel like that was a big deterrent for me when I first started as a professor it's like, I don't want to print 50 packets.
Yeah, for sure.
And then collect 50 packets.
Then carry 50 packets home. Do you know what I'm really, but I love a lot of things about this, but I really love something that physics really struggles with is, equity is a big issue in physics. And one of the things that kind of keeps coming up is the idea of people like feeling connected to their communities and how they could serve their communities. And so it seems like for different types of learners that has differing importance, but for, it's definitely a thing I've noticed in Ireland is people, and it sounds ridiculous, but when you meet your uncle at a wedding and they're like, what kind of job are you going to get? Like that's an important thing to think about. And this is just such a beautiful way of like bringing in like these local things. Like this is how you could impact your local community and, your job. So I love that. Like where we are at Humboldt, or where I was, we had something called place-based learning, which was really talking about students feeling like the connection to the local area. And it's something that physics really has a bit of a crisis with. Like it's hard, to create like what kind of job you're going to get if you're not going to go and get a PhD and be a professor. And there is jobs, but it's not clear in students' minds. Like,
oh, totally.
Yeah, it's so cool because all of this stuff just feels so alien sometimes when you're doing science, and it's like someday when I've spent another 20 years studying, I will do something. But this is so cool that you're like, look, we're doing these calculations right now and we're talking about this stuff with the skills we have. So I love it. I love everything about this. It's brilliant.
Yeah, thank you. I appreciate. I have to say, I don't think chemistry is like perfect at equity either.
No,
I'm
it's
sure
just
Claire
compared
would
to
agree.
physics, it's a lot better. But yeah.
And I think also too, I think one of the things I've learned as like a faculty member now that I'm on the other side is, and it's weird. I talk about that a lot, and I think, and I've been here for 5 years, but I act like I've, like never imagined myself being a professor, and that is kind of true. I don't think I ever really knew that this is exactly what I was going to do for a living, and that actually think kind of helps me because I don't maybe think purely academically, but at the same time, like we're like products of our training to a large extent. And I do think that also we're very busy people, and there's a lot of time, we have a lot of commitments. And I think that that's like one thing that I've really come to peace with in the last couple of years is like, I also want to do more. Like I said, I don't do any projects that are as sort of service oriented or like you said, what was it called?
Place-based.
Yeah.
Place-based. I like that a lot, and I'm now starting to make connections. I'm also starting to realize how long it takes to make those connections
Yes.
in your locality to get access to those types of topics and resources and people, human resources, even to just people who can help you out. I'm now learning that that takes years. So I have to say, just be patient. And if anyone's considering doing this, I would say just be aware of that and don't feel like, some people might be so inspired to do something like this that they are going to be more active. But if you don't have the bandwidth, I would say that there's definitely a level you can approach this at, that it doesn't have to be, you might have this wonderful idea and it's like, don't let, perfect get in the way of good enough,
Oh
So
my
I
gosh.
think that that's a, yeah.
Yes, amen to that. I love that. But yeah, and I think I really appreciate you also saying like that you're not a sociologist or whatever, because sometimes it just feels like, oh, look, I can't even. But you're finding a way that you're engaging with it that feels comfortable. Because that's the thing that I find off-putting. Sometimes I'm like, oh, I just can't. I'm not an expert in this particular discussion, so I won't start it. But I love that you're saying you found a way to do it comfortably.
Yeah. Well, and I think it's interesting too because you could imagine, say, teaching a team teaching a class with somebody from social sciences or public health, which I guess if your school has a public health department, or environmental science if your school's an environmental science department or something like that. But at the same time, I think that comes back to I've had those ideas. I'm like, I should really ask someone to come in and guest lecture for a day. But then, maybe in the future that'd be a great idea. But it's also one of those things, again, don't let that be like, oh, because I, haven't
Totally.
found these connections, I'm not going to do it. Because I think for me, that's like one of the things where I'm like, oh, I'm doing what I can do one day at a time. But I think that would be a wonderful idea if someone had the bandwidth, in their course, load to actually do like a team talk class. I think that'd be awesome. I think that especially analytical chemistry, but I'm sure in physics and I'm sure in even other parts of chemistry and other parts of, for sure in biology and other sciences, you could imagine having some class that connects,
Yeah.
multiple people from multiple departments in this way and gets people really thinking about problems and problem solving and sort of, and ferreting out those details of what roles and because I think, I did my postdoc at a national lab and I worked in a group of engineers and I was not an engineer at all. I was a chemist by training. And one of the things I learned in that setting was just the language that people use is just slightly different and the
Totally.
approaches are slightly different. But like once you learn what the other communities, their language and their approach, you can sort of actually be much more productive once you sort of break that barrier. And I think that a class like that would do a great job at that.
I always had like I've been in various research groups like as a PhD student, and there was always one chemist, and it was just so funny because the chemist was like, "Okay, so will we just try it?" And I'm like, "Whoa, hang on, we need to do a bit more like planning and like." But they were always right, but I was always such a nervous Nelly, and like they were always like, "Well, why don't we just put it like get going and see what happens?" But everyone should have chemist, is what I'm saying. Otherwise, nothing gets off the ground. So yeah.
Yeah, I agree. Biased here, though.
Well, it sounds like you've got great packets, great projects. Is there anything that we didn't cover that you wanted to share with our listeners?
I forgot to say, too, I do have them do a reflection where they look up their... we have a lot of students from all over the country. We're, like I said, in Omaha, Nebraska, but we probably pool or pull students from the West more so than the East, for example. And we get a lot of students from California. We actually have a lot of students from Hawaii, just because Creighton has an interesting connection with the state of Hawaii.
Oh, wow.
And it's one of the things I think that's actually the students really enjoy and do really like digging into is at the end I have them look up a local Superfund site in their home region,
cool.
and then write like a little quick reflection on it, like 150 words, and sort of what are the contaminants that are the problem, what was the origin, what's the current status, and sort of what is the remediation plan moving forward, and then thinking about, what could a chemist do? Is there a lot of them are remediated, which is good news for what people look up, but for some of them that aren't, or some of them that are like on a delayed timeline, it's actually some students get really interested and engaged, and I think that that's a great way to end the topic in a way that, I don't want to ask so much from students. I think that one of the things I learned doing this project, our packet in this particular one with organic pollutants, is that students really spend a lot of time working through this, but they also have a lot of other stuff going on, and I don't want to just like consume them for a week. So, but some students will get that excited about it. So, it's a nice little way to like just finish it off and sort of, if that's something you want to revisit in the future, put a pin in it, and now because most students said they didn't know about these things in their own community. So that was actually kind of powerful, I thought, too.
That's really cool. And that reminds me of a super detailed question I had. I'm all about the details. But you have packets. How many times a semester do you have a packet? Is it like one packet ends, the next one starts, or what? How does that happen?
Claire, you like hit on a topic that like I'm still trying to figure out. So actually, one of the things I want to do, I was on sabbatical last spring. I'm not going to be teaching quantitative analysis lecture until spring, because we're on 3-year rotation. So I'm teaching labs currently, but I will be back in rotation for this lecture in a year or two. And I think one of the things I want to do is be really intentional. I have packets per topic, and then usually I have like some integrated theme about, maybe the theme might dominate the packet. The theme might be like half of the packet. So it's sort of the intensity of the topic. It differs by module or by unit. Mm-hmm. But one of the things I would like to be much more intentional about are the coverage of issues. So I think I mentioned that I've done other things than environmental issues too. Like I've done like social justice, and there's like a little homework I do during spectrophotometry, or maybe is it spectrophotometry or sampling? Oh geez, I'm having a moment. But either way, it's in one of my packets on like racial bias and pulse oximetry. And it's really nice because it fits within this I think that's actually statistics. It's in my statistics packet. But like then it also has a spectrophotometry component. And so I have a little, a social justice topic, I have an environmental justice topic, and then I have sort of other ones that are more specific to the region throughout. And I'm like, I want to like almost create a matrix of like, okay, these are my packets. These are like the technical content. And then these are like the themes that are like introduced in each topic. And so to make sure that I'm actually getting like comprehensive coverage of the things I want to do. I'm not the type of person, I know some people, like I said, will like take a whole semester and do one thing. I'm kind of a buffet style person.
Me too.
It's a lot to commit to anything for a semester. Do you know what I mean? And yeah.
Yeah. And like, what if someone doesn't like it? And then I'm like dragging them through the whole semester on this topic that doesn't resonate with this person. So I feel like getting some variety in there, and if it resonates with a couple people each time, and those people are different every time, that'd be great. So, yeah.
That's cool. I love that. It's really interesting. So I also call my homeworks packets, but they're very different. They're focused on particular quantitative skills that I want them to learn, like learn how to do solubility problems, now learn how to do buffer problems. But it does occur to me that I could insert in there some more, applied applications, you know what I mean? Like something interesting. In addition to learning this skill, here's some relevant topic. It could be fun too. So anyway, I really like that you have your packets where you've got the analytical content, and then the environmental or social justice content, and the different themes that go through that, all integrated into the same packet assignment. That's really cool.
Yeah, I know some people call this, context. I think it's like context-based learning. And I think that, I'm not really great with the lingo, because I feel like these are a lot of these words are things that people do or have done for a long time, but haven't quite came up with a word for it.
Yeah, totally.
but I do think, yeah, like if you just change the context that some of the questions are asked, like, and some of the things I'm like amazed, like I don't even, like I'll have a calc-based problem and I just have to add a sentence and all of a sudden we're like in the theme, you know, it's like,
I totally agree.
yeah. And it's like, I don't even have to change the questions I used last year when I introduce a theme sometimes. I'm like, oh geez, I'm like, I could have just been doing this all along. Like, you know,
I found the same thing.
Yeah. But I will say though, it does take a little bit of energy and you know, I think like my coworker actually is really great at this. My colleague, she does, she's a very active reader of CNEN, which I'm a sometimes reader of the Chemical Engineering News, which is like an ACS magazine that comes out weekly. And so she's such a great resource to me because she's like, oh, did you read this article on, you know, I don't know, microplastics in, I don't know, this type of fish or something like that. And I'm like, no, I didn't yet. And she's like, oh, I think that'd be such a great question to frame for, I don't know, like say a unit on, I don't know, like polymers or something. I'm like, oh yeah, you're so right. Like, that's so great. We should talk about that when we talk about polymer analysis. And like, I didn't even think about that. And so, yeah, things like that.
I love that oh, sorry, Karen.
No, you go ahead.
Well, I love that you keep acknowledging workload as you're talking, and I think that's super important. And just everything you said about like you can just sprinkle in a little thing, or you can do like, because sometimes it's totally off-putting to be like, oh, I'm going to invent this whole like, yeah. So I because I was going to say, like, when you run out of steam, I had one semester where I was like, I'm going to have all my physics problems not be violent and not be sports, and man, I was regretting that like at week 8 when we were doing a momentum, and I was like, I can't do anything that isn't bullets. So, but anyway, I was like regretting to committing to that out loud to students. But yeah, so I like the idea of sprinkling stuff in. That's lovely.
And the thing I was going to say was just that I was reading your ACS symposium chapter, and you had a bunch of topics that did exactly what you said, and I really liked that word. Be like, the last line is develop a method for measuring lead in soils, but then the first couple lines are, there was this lead toxic spill, and it's right here, and here's the history, and so your task is, and that just gives so much more context. So I love that.
And I will say too, with context, I talked about how like emotions bring people in. It is sometimes really hard to harness that. And students get really distracted on the question. So you might say, develop the method, and then they start talking about all these things and you're like, oh, like you got to answer the question.
Sure. That makes sense. It'd be really easy to go down the path of all the implications of the lead in the soil and all that. Yeah.
That does happen sometimes. You're just like, okay, we got to answer this question. We can't, like we have to talk about it, but we also have to move on. So I will say that is a nice sort of side effect is that students get engaged, of student engagement is that they get maybe a little too passionate, and then you kind of have to redirect them. So
I love that's a great
good
problem.
to
Yeah,
have.
that's exactly what I was going to say. Like, that's not normally something that happens. Joel, this is so interesting. I'm super excited and blown away and thinking a million thoughts. Thank you so much for being on the show. And I have a feeling we're going to have to bring you back to tell us about the packets in more detail. But yeah, it was great talking with you.
Yeah, thanks so much.
No, thank you guys. And I had a great time, and I'd be glad to come back if you ever had me. But thank you so much.
Thanks so much for joining us on the Professor Podcast with Ruth and Claire. We're delighted to have you as a listener, and we would love to hear from you. And if you want to email us, our address is contactprofessorpodcast@gmail.com. We'd love to hear any of your suggestions for future shows or professor quotes that you might want to share with us, or even just things that have come up for you when you were listening to previous episodes. And if you've been enjoying the podcast, we would love if you would spread the word. So the best way to spread word is by telling people if you think they should listen to it, or you can leave us a review wherever you listen to your podcasts. Thanks so much for joining us, and we'll see you next time.